You can divide a pentagon into 6 equal parts, with the 6th part being the center of the original pentagon, to scale with the original pentagon. This is to say that the original area is 1/6 of the original area of the pentagon. Since this inner pentagon is a self-similar version of the original pentagon, you can actually put another pentagon inside of the pentagon that you put inside of the first pentagon. This portion of the shaded region is 1/6 of 1/6, which means that it's 1/6 squared, and you can add it to the original to create 1/6 squared plus 1/6, which is really 1/6 to the power of 1. This creates another pentagon, which means you can nest the same pentagonal shape into this. I closed it off for very clear purposes because I don't have a fine enough acrylic marker, but the idea is that you can actually keep going on into the center, creating ever smaller, proportionally smaller trapezoidal figures, and thus creating an infinite series of 1/6 to 1/6 squared to 1/6 cubed, and so on and so forth. And if you look in general over the region of the shape that I'm shading in, the total area of this bit is 1/5 of the total area of the pentagon. We now have a visual proof for adding up the powers of the inverses of 6, and adding that up comes to 1/5. All polygons can be broken down in this way, which leads to a really elegant formula for calculating the sums of an infinite series of the inverses of powers of a certain number. This is the formula. You can see that this is the original... Actually, let me find a better way to visualize this. X is the number of sides to any polygon, and this is the area of the shaded region, which we already know is going to be self-similar with infinitely nested versions of the original polygon. Subscribe if you want to know what I'm thinking about tomorrow. This has been Sophnautica.